Okay, so I have taken a little bigger array so that we get the intent and idea better. First thing that this question is asking us to do is it is saying pick any two indices and subtract 2 power something from it. If I give you a number, let's say if I give you a number as 17, 17 if I write in binary form, it is 16 plus 1. Is that right? 16 and 1. So 16, 8, 4, 2, 1. So 16 is 1. This is 0. This is 0. This is 0, 1. So this is 17 in binary form. And second thing is any number can be written as sum of powers of 2. So it is 16 plus 1. So now when we are saying we have to reduce every number to 0, if you have to reduce any number to 0, how many operations will it require from us, minimum operations to make it 0, if we are allowed to subtract only powers of 2? How many operations do you think it will take for 17 to be reduced to 0 by subtracting any power of 2? Yeah, guys, can you respond? Okay, Sarayu says 2. So Sarayu, you will subtract first 16 and then 1, or vice versa. You subtract 1 and then 16. So ultimately, every bit position that is set, we can say every bit position we are making it 0 in one operation. Is that right? That is our first observation. So two things that I'm kind of building this on is, first, every number can be written as sum of powers of 2. Okay. And we are saying that if we have to reduce the number to 0, to reduce number to 0 by subtracting power of 2, we need how many operations? Now, how will you express that? How many operations are needed? We need operations which are equal to what? Equal to what in binary form? If you want to reduce a number to 0 by subtracting, it is equal to number of ones in binary form, of that number, because each one is representing one power of 2. Okay, these two ideas are clear. Now we are talking about making, for now, rather than talking about counting all these subarrays, let's try to see on entire array, how many operations will it take for us to reduce entire array to 0, if it is possible to reduce entire array. So at any moment, for example, if I give you three numbers in this array, this number has 0th bit set, this number has 0th bit set, other bits are 0, other bits are 0, and this number doesn't have 0th bit set, and there is one more number, let's say 8. So can I say in first iteration I will pick these two numbers? Or let me make it different. Yeah. We want to reduce this entire array to zeros. Every time you will pick two numbers, you will subtract a power of 2 from it. So which numbers will you pick, or what will be the basis of picking a number? What will be the basis to pick two numbers? How to pick two numbers to subtract? Which two numbers you will pick? What will be the criteria? We have to make entire array 0. Right now I'm talking at an array level. To make entire array 0, operation you are allowed to do is you have to subtract some power of 2. So from this array, which two numbers will be wiser to pick? What will be our criteria of picking two numbers? So if I'm subtracting, imagine, yeah, Lokesh, that is right. Imagine if I'm planning to subtract, 8, if I'm planning to subtract 2 power 3, this is 0th number, first number, second number in binary form. Which two numbers I can pick? Can I pick index 0 and index 2? Will this be the right selection? Can I subtract 8 from both of them? Because I want to make this entire array 0 by subtracting powers of 2. In one operation, we are saying we can make this bit as 0 from both these numbers. Another operation, we are saying we can make this bit as 0 by subtracting something from both these numbers. So can I say here I will do -1 and -1, because -1 is nothing but it is -2 power 0, -2 power 0. And here I can do -2 power 3 from this and -2 power 3 from this. So my two operations will be sufficient. Okay, Lokesh Gupta says any two would be okay, since when we do XOR, we get 1 XOR 1 0. Yes. Yeah. So first is like we need to get two numbers whose a particular bit is set, and then we can unset that bit. Okay. And this is, I think, where Anand was helping us to kind of reduce. So now if you see, I am seeing these numbers. This is the array given. Let's say indices are 0, 1, 2, 3, 4. Can you tell me which all indices of this array have 0th bit set, first bit set, second and third bit set? This is bit position. 0th number is 4. Which bits are set in 4's binary form? Because in 4's binary form, which bits are set? Can you work out and tell me? Okay, second bit indices of array. I'm just going to put in array index 0, we have second bit set, because 4 in binary form is 1 0 0. This is 0th bit, first bit, second bit. So second bit is set in 0th index. What about first index? In 3, which bit positions are set? 0 and 1. Yeah, so 3 in 3 binary form is 0 1 1. So 0th bit is set, first bit is set. So 0th bit index 1 and first bit index 1. Now same way, if I ask you which bits are set in index 2, which bit positions are set in index 2? In number 1, 0th bit is set. So I will say index 2 has only 0th bit set. Index 3, value, which is 2, has which bit set? First bit set. So index 3 has first bit set. What about index 4 value? Whatever is the value at index 4, which bits are set there? Okay, second. Now if you see, 0th bit is set in 1 and 2. We can choose them together and we can make them 0. Same way we can choose 1 and 3 together and make them 0. We can choose 0 and 4th index and make them 0 by subtracting 2 power 2. Is this making sense? Okay, is this making sense to everyone? Yeah, so if there are even number of numbers which have a particular bit set, then we can reduce them to 0 easily. And even number of, if I have even number of number whose bits have to be reduced to 0, then XOR comes to our mind. We know XOR of a bit position, two numbers having same bit position set, if you do XOR of them, that reduces to 0. Yeah, so ultimately we are trying to find out if indices of the array make the subarray XOR to be 0. That is what we are talking about. We are saying if any three indices, if you do XOR of them and XOR becomes 0, that means every bit position has a corresponding pair in this subarray. 1, 2, 3. 1 is 0, 0, 1, 2 is 0, 1, 0, and 3 is 0, 1, 1. If I take XOR, 1 will cancel with 1, becomes 0. This one will cancel with this one, becomes 0. This is 0. So this is what we are trying to find out. Now it is a subarray question. So we try to work out the prefix XOR subarray for it. So can everyone write the prefix XOR subarray? Prefix XOR array. If the original array is given to you, you need to construct a prefix XOR array. This is A, this is P. Yeah, can you guys fill this in your notebook and let me know once you are done? So P of 0 will be A of 0 and P of any index I will be A0 XOR A1 all the way up to AI minus 1 and AI. So we are taking a prefix XOR, and I can recursively also write it as this is nothing but prefix XOR of I minus 1 XOR AI. This is what we know about prefix sum or prefix XOR already. Using this idea, just fill the prefix XOR for every index. And then we will see how do we use prefix XOR to find our answer. Okay guys, so what is P of 0? What should I put here? Prefix XOR up to index 0 is how much?
Same element.
Same 6. Up to 9? Yeah, it will be 9 XOR 6, so it is 15. I can also write it as 9 XOR 6 just for readability. Same way, if you do 9 XOR 6 with 5, you will get some prefix XOR. So 15 is 1111. You do XOR with 5, which is 101. This will become 0101, which is 10. Okay, next. With 1, if you do 10's XOR, it will become 11. With 11, if you do 2 XOR, 11 is 1011 and 2 is 10. So it will again become 1001. It will become 9. Okay, what is fifth value? Yes, what is the fifth value? 9 XOR 3, it is 10. Okay, what is sixth value? 15. What is seventh value? 7. Eighth value? 6. Ninth value? 1. And just for ease, let me add two more values here. Let me add 1 and 0. If I had two more variables or two more elements, 1 and 0, what will be the next two values? Yes, what will be the next two values? It will be 0 and 0. Is that right? Okay, so once we got prefix XOR, we will see how to use it. Just answer these questions to me. Imagine if at any index P of I, if the value is 0, what is the meaning of it? If Pi is 0, what is the meaning of it? Pi is 0 means?
Set bit number of set bits are present for even times up to there.
Yes. Or can we say subarray from index 0 to? From index 0 to index I has XOR as 0? Is that right? That beginning till here, we have a subarray whose XOR is 0, and that will become a beautiful subarray because only that subarray whose XOR becomes 0 is a beautiful subarray. So 0 values are of our interest. So from this prefix XOR array, how many such subarrays we are getting, which are beautiful subarrays whose values are 0? How many such subarrays are there whose which are beautiful subarrays? So we can say 2 because there are 2 0 values we are getting. Okay, this is half part of our answer. Second part is, imagine if pi value or pl value up to some index left, let me pick some index left which is here 2 and some index right which is 5, their values are becoming same. If you say this was 10, this was 10. So if prefix L is equal to prefix XOR of R, this also indicates something to us where R is greater than L. Okay. What this indicates is, see, let me write it expanded form. Prefix of L means, do you all agree with me? It is A0 XOR A1 all up to AL. This is prefix of L's definition. And since R is greater than L, can I say this is nothing but A0 to A1 to all up to AL minus 1 to AL to AR? Are we clear with this part? If R is greater than L somewhere, up to L will be part of it. Yes, is this making sense? Let me make this L and this L plus 1. That means L will come on the way to prefix of R. Now, if I XOR with this entire value on both sides, this side and this side, if I XOR with these two values, what will I be left with? If I call this value as PL, if I do PL XOR here and PL XOR here, both sides, if I do XOR, left side will reduce to, what will left side reduce to? 0. And what will right side reduce to? PL, and this will become 0. It will be 0 XOR A of L plus 1 to A of R. Can I say two values are same? If these two values are same, the meaning is this to this XOR is 0. This is the conclusion we have drawn, that this to this XOR is 0. If PL is equal to PR, that means subarray from AL plus 1 to AR is beautiful. Is that right? Is this conclusion making sense? Yes. So ultimately, we are talking about these two things only from prefix array. Two zeros gave us two array subarrays already. Now let's see how many values are equal. 6. Before 6, there is no other 6, so ignore it. Before 15, there is no other 15, ignore it. Before 10, there is no other 10, ignore it. Before 11, there is no other 11, ignore it. Before 9, there is no other 9, ignore it. Before 10, how many 10s are there? Before this 10, how many 10s have we seen? 1. So can I say there is one more beautiful subarray? My one count increased here, so total 2 became 3 now. Before 15, how many 15 we saw? Before this 15, we saw one more 15, so there is one more subarray. Before 7, did we see any 7? Before this 7, did we see any 7? No, so 7 cannot give any other subarray. Before 6, we do not see any subarray, or we see. 6 was already here. Now, if we have to check how many 6 have come before it, where can we remember that value? Yeah, we can use a map, we can use a dictionary. So every time we are moving forward, we can keep incrementing the frequency count of current prefix XOR. Later on, we can use that, right? So this 6 gives us one more. One we never saw earlier, ignore it. So total is 5 answer for this. And now if we connect to the example which Anand was giving, Anand was saying if you have prefix XOR array, which is something like 9, 4, 2, 0, 4, 2, 0, 4, 2, 6. If this is your prefix XOR array, imagine, then can you work out the total count of beautiful subarrays? This is the example he was explaining. And you know which values in prefix array are of your interest. From above prefix XOR array, can you count and type the count in the chat? I think that would be, Anand, is that fair? Like, is this what you are trying to give with that example?
Yes. Yes.
Okay. So now once people compute it on their own from prefix XOR, I think then it becomes more easy to grasp for everyone. Okay, I got one answer. Yes, Sarayu, can you unmute?
Yes, sir.
Yeah. So how did you compute that up to 9?
Yes, sir. Up to 9, it's 0.
It's
It's
0.
0. And when it comes to 4, again it's 0. When it comes to 2, it's 0.
Yeah. So you are along with this, you are building a map also. 9 occurred one time, 4 occurred one time, 2 occurred one time.
And when we come to 0, we'll increment the count by 1.
Yeah, because it is already 0. So we increment it by 1. And now our map has 9 one time, 4 one time, 2
Store it
one
in
time,
map.
and 0 one time. Yeah. Now when you come to 4, what do you do?
We'll increment the count, and in map also we'll increment 4.
Yeah, 4 occurs 2 times, but with this 4 reoccurring, there was earlier one 4. So can I say our second subarray found now?
Yes, sir.
Okay, because 4 is occurring earlier also. Okay, now when 2 comes, what do we do?
Again, we'll increment count, and in map also we'll increment the 4 count by 1.
2's count by. Now 2 is
Yes,
occurring 2
sir.
times. Okay. When we come to 0, what will you do?
We'll increment the count by 2.
Yeah. 1 is because we found a 0, so prefix 1 is simply prefix subarray. And second is there was a 0
And
already.
again, in the map, so we'll increment by 2.
Yeah, so here the count will become 5. And this will be 2. Okay. For next 4, earlier 4 occurred 2 times.
Next one, again, we should increment the count by 1.
So 5 will become,
In map
no,
also,
not by 1. Sarayu, if you see, there are 4 occurred 2 times earlier.
yes, sir.
So how many subarrays those 2 4s are giving you?
2 separate.
So it should be 7, right?
Okay.
So now
Then we'll
4,
increment again 2 by 2.
4 by
Yes, sir.
okay. Now you see another 2. So what should you see at 2? How many times 2 occurred earlier?
2 times.
That means if you see same value again, it gives you equal number of subarrays, like 1 by this, 1 by this. So it becomes 9. and 2 becomes now 3 times. Yeah, and 6. Did we see 6 earlier?
No, sir.
No. So count remains 9. So answer is 9 in place of 7. So what did you miss out?
I missed out the count of 4 and 2. I only counted it one time again.
Yeah. But if 4 occurred 2 times earlier, they will give you 2 new subarrays.
Yes, sir.
Okay, others,
Uh,
is it clear?
sir,
Yeah.
sir, can we also initialize our map for 0 count as 1 so that we don't have to handle two conditions?
Okay. Yeah, that's another good idea. So what Kaushik is suggesting is before even starting, if in map we put 0 is 1 time, then we will not have to handle the 0 case separately. Like, yeah, this 0
Sir,
is, yeah.
sir, or else we can do that. Like all other numbers, we can also consider 0 as same, but at the ending, we can add the count of zeros in the PXOR array.
Yeah, that's another thing that one can do. Yeah, so multiple ideas. One idea I was discussing is you start with count 0 without taking prefix map. So it is like if you find pi to be 0, if pi is 0, you directly do C++. And second, you do if in count you are also adding count is equal to in map whatever is the frequency of pi, you are adding that to the count. And in the end, in map, you are incrementing the count of pi by 1. This is one idea that we discussed. Here we are handling 0 case separately, separate handling. Second approach that Kaushik suggested was saying that rather than doing this, what essentially you can do is approach 2. In your map, you can directly say 0 is occurring 1 time, so you will not need this check. Then for every index I, from 0 to n minus 1, what we can do is we can directly say count plus is equal to map of pi, and map of pi plus equals to 1. Right, Kaushik? This is what you are suggesting?
Yeah, exactly.
Okay, this is second thing that we can do. And we are still looping over a prefix XOR subarray. There is third idea also that we can do. And third idea is this. What we can do is just loop over prefix array and count frequency of everyone. So if we loop over prefix array, what is the frequency of 9? How many times is 9 occurring? 9 is occurring only 1 time. 4 is occurring 1 time. Sorry, overall. Can you tell me overall 4 is occurring how many times? 9 is 1 time. 4 is occurring 3 times. What about 2? How many times 2 is occurring? 3 times. How many times 0 is occurring? 2 times. 4 we have taken, 2 we have taken, 6 is left. 6 is occurring 1 time. Now, if you consider the values which are not 1, values which are more than 1, for example, 4, if there are 3 4s, 4 was here, 4 was here, 4 was here, how many subarrays are they giving? So this 4 is getting 1 subarray. This 4 is getting 2 more subarrays. This 4 to this and this 4 to this. Total, they are contributing to 3 subarrays, right? Which is nothing but you can also derive that number from here. It is whatever is the frequency here, you can say if this is f, if this value is f, it is contributing f into f minus 1 by 2. Those many subarrays it will contribute. So basically build the map. In the end, loop over every value in the map and just use this formula count plus is equal to this f.
Sir,
Here also we'll have to make one correction. 0 should be 3 then.
Okay. Yes, that is right. So otherwise zero will have to be added again. Yeah, zero should be made.
Yeah, or for 0, we can do f into f plus 1 by 2.
Yes. Yeah, but that is a better idea. Initialize 0 as 1 and then utilize this directly. Yeah, guys, is this making sense now? Okay, so this was our third question. Any doubts, any questions from anyone? Okay, then we should move to the last one. Okay, why initialize with 0? Bhavna is asking. Kaushik, would you like to answer that?
Yeah, Bhavana, see, we have 2 as the frequency for 0. So all the subarray ending with 0, yeah, for this case we have 3 zeros. So can you tell me how many subarrays are there which is ending with zeros in total? 6, right? Now here the frequency is 3. If we do 3 into 2 by 2, do we get 6? Like 3 into 2 by 2, you get, so you are missing all the subarrays which is ending with 0 but starting at the index 0, because initially the XOR is 0 and from there we are starting adding one by one element. So for 0 we have to handle it separately, or we say that map of 0 is equal to 1 when we start with it.
Yeah. So ultimately, if we see 0, 0, 0, it is giving us this 0 is counting there is one subarray. This 0 is counting there are two subarrays ending here. But we are not considering those subarrays which are from beginning. Beginning to here also is beautiful. Beginning to here also is beautiful, and beginning to here also, because prefix sum 0 is special case. These three are missing out. So for that reason, if we assume there is a 0 already there, then that 0 will make one array for this, two for this, and three for this. So that gets added automatically. Okay, are we good with this question? Cool. Let's jump to the last one.